Hello and welcome. We have a fun case for you this time. This is called Whodunnit by Harry Watson. In this case, we are investigating a crime syndicate going around the fictional land of ExcelState and committing all of these atrocious crimes. And as part of our investigation, we have intercepted a bunch of communication from this crime syndicate. And our job is to decode these messages and find out who has committed all of these atrocious crimes. We have a table here of keys from certain senders to certain receivers, and all of these messages involves two kinds of shifts. One is an ordinary shift, which is each character is shifted by a certain number of characters to the new one, and then a long shift, meaning at whatever position that the character is in the message, it has a certain shift. So this is going to be really fun. I really enjoy these kinds of code breaking exercises. Let's see if we can get this solved in 30 minutes. And here we go. Now, even though level 1 says that we should use the code and car functions, I'm going to use Unicode and Unicar because these are simply extensions of the original code and car functions. That way I can also use these codes to answer the question for level 2. Now, level 3, we're going to work with an ordinary shift. So in the example here, we're going to start with the letter C. Now, first thing we're going to do is I'm going to find the position of C in the alphabet. To do that, I'm going to use a mod function with a shift of 32. C is in the third position, that is correct. Now I'm going to add the original shift, which brings it back to 0. That's not quite what we want, because imagine that we are looping around. I want it to go back to 26. So this adjustment to the formula does make it 26, and that should then give me the correct answer. Once I add this car function back in, plus 64 to bring back the range of capital letters. Now in level 4, we are going to take an entire word and we're going to apply a shift to an entire word. So here I'm going to start my model. I'm going to bring the game information for example 4. So there is an encoded string and a shift that we need to consider. Now on this model, I'm going to start on line 10. And you're going to notice I'm going to use a lot of dynamic arrays. This is really going to help as all of the encrypted codes are all different lengths. So first I'm going to bring in the word character by character. A mid and sequence function will help me do that. I am then going to bring in the sequence. That's going to help me later for the long shift because the long shift is different depending on the position of the character. Now in this third column, I'm going to bring out the code of each character, basically the position of where it is. And now I'm going to add the shift. Now to do the shift, I'm going to do something a little bit unique in that I am going to add the semicolon, which tells me to split the numbers. And I'm going to repeat this string an equivalent number of times as the length of the original character. Now when I do that, I can then add this text split, which will then split it into columns depending on the number of repetitions that it has. Now that I have my new code, I can bring out my new character. And that brings me the answer to the question. So let's concatenate that new string and let's get the answers to all of these other 20 questions. Now in level 5, we have a pretty difficult challenge. We have an entire message here, and we need to decrypt that entire message using the same method as we just talked about. Now we have one key for this message, and that key that it was encrypted on a certain day. And when it's encrypted on a certain day, we know the first word of these messages is going to be that day. So we're going to use that to identify what I'm going to call the key, or basically, that's going to tell us how much is going to be our shift for every single character. Now, since there are 7 weekdays, I'm going to repeat a certain pattern 7 times to find that key. I'm going to start by taking the word of the day, splitting it up. I'm then going to find the code for each letter of that day. And then I'm going to find the difference between the code and the encrypted message, those first however many number of characters as the weekday, and take the difference to see if the ordinary shift then matches. If it does then match, then we have found our key and we have cracked the code. Now the way that I've written this formula, I've written it so that I can easily copy and paste it across. So for example, for the length, for how many rows of the original message we're taking, I am not just simply taking the first 6 characters, I'm taking the number of characters in that weekday. Now to find out whether I have found the code, basically what I'm going to do is I'm going to see if that ordinary shift is equal for all 6 letters, which I'm going to know by taking the maximum difference, subtracting the minimum difference. If that is 0, then we know we found the code. That means all the codes are equal. Now I'm going to go ahead and repeat this pattern. The error will be taken care of shortly. So the reason that the error is coming up is basically because the original code is not kept as an absolute reference. Basically, copying and pasting is taking that original code and shifting it along. I'm going to go back and make that an absolute reference. Then I should be able to copy and paste throughout all of the keys. Now, when I get to Sunday, you're going to notice that's how we know it's a match, because you see the ordinary shift for Sunday is all equal to 8, meaning we know that this original message was shifted by 8 characters, and we are going to use that to decrypt the message. Now here what I'm going to do is I'm going to take my decryption columns and highlight them in red, just so that you and I can see them easier as I'm entering these formulas in. So to find the ordinary shift, I'm going to XLOOKUP, look for that 1, which is what's telling me where we found the actual shift. I'm going to use my repeat trick again, so that applies to every letter of the original code. Now I'm going to find the new code, taking the original code and subtracting that shift out of it. Now I'm going to start by finding the new car. Now one thing that I haven't taken into consideration yet is that shifts and numbers spaces and numbers are not shifted. So I'm going to add a column in here to tell me whether I'm going to shift the character or not. Basically, it's going to be a little bit tricky when I enter this in, but I want to find out, is the original character a number, or is it a shift or a space? If so, then do not shift this character. There we go. Now I can use these 1s and 0s as an if statement. So if it's a 0, bring back the original character. If it's a 1, then apply the shift. Now I have my decrypted message. I'm going to go ahead and concatenate all of those characters together. And then for this level, the question was, what is the last word in this message? So I'm going to take a text after function and apply -1 for instance number. -1 basically means the last instance of this character. Run through my data table, and then I get all of the answers for this level. Level 6, now we're going to apply the along shift. The along shift basically works that each character is going to be shifted a different multiple of the shift for the weekday. So I'm going to create my name range for the long shift. I already created a named range for the weekday earlier, so I'm not going to redo that. Now you notice that the weekdays are actually different from the first to the second one, but in our formulas you're going to see that it's not going to really identify that difference in an XLOOKUP function. It's case insensitive, so that's perfectly fine. So now I brought over 4 pieces of information. I brought the original message, the day it's going to be encrypted, the sender, and the receiver. The last 2 bits are going to be important because there is a different code between sender and receiver. We're going to see that in the people table here. Now I'm going to find that code based on the sender and receiver that it sent us. So here the sender is Olivia. I'm going to find that in the top row. The recipient is David. I'm going to find that in the second column here. Now the code is 5249, so we know that the original shift is always going to be 5249. Now the along shift is going to depend on the weekday. So in this case, the weekday is Wednesday, which means we're going to have an along shift of 2. So the first character is always going to be shifted 0 times. The second character is going to be shifted 2 times. The third character is going to be shifted 4 times, and so on and so on. So I'm going to add this function to calculate that along shift. Now you see what I did originally is I tried to use the repeat function and the semicolon. I actually don't need to do that because adding in the dynamic array in A10 is already going to apply that to a certain number of rows. There we go. Now I'm going to go ahead and find our new code, which is going to be adding in the original code plus the shift plus the along shift. And then I'm going to use that to find the new code. Now, here is the problem. I noticed that this is not matching the original example. And that's because I forgot to take the original word and find the unit character values. So what I've been originally doing up to this point was I've been basically finding the position of that letter in the alphabet, but now we need the Unicode value. So I'm going to go ahead and change this formula here in C10 to find that value. Now my new string is matching up properly. I'm going to go ahead and concatenate that, and I'm going to use that to answer all the questions in this level. Now level 7, we've gotten to the final level. Basically, we have a group of messages here in the correspondence tab, and we are going to use those to identify who committed which crimes. Now this is going to take everything that we've done up to this point. We need to find the key, which is going to be the weekday. We need to find the ordinary shift. We also need to find the along shift. So there's a lot to take into here. I'm going to go ahead and continue using this model that I built from levels 4 and 5. And I'm going to use this to try to crack all the codes. So you see here what I'm doing is for each of my keys, I'm going to add another column for a long shift. Basically, I'm going to take up that weekday and I'm going to find what would be the appropriate along shift for that weekday. Now there are other formulas I'm going to have to edit. For example, I'm going to have to take the code functions and replace them with Unicodes. And now basically what I'm going to do is I'm going to try to decrypt this message using this ordinary shift. Now once again, I only need to take a certain number of rows from the original code, so I'm going to add that here in this formula. And if the ordinary shifts all match, we've cracked the code. For Monday, it did match. So we're going to go ahead and continue and apply this function to all of the other weekdays. Now you see here Saturday, we hit a match. All of the ordinary shift is 8617, which means that is the ordinary shift, and we're going to use that to crack the code. Now here I'm also going to add the along shift column in my decryptor. Basically, I'm going to look for the 1 again. The 1 tells me which weekday it is, and I'm going to find the along shift in the second row. Now remember, the second row is along shift times 1. So that's going to tell me what the along shift should be. And then once again, I can apply the sequence number to get the along shift for every single character. Going to go back and find the unit character for the new code. That gets me the decrypted message. Going to go ahead and concatenate that. Saturday I committed ACOS. I'm going to go ahead now. Remember, this time we're not actually going to use the case numbers. We're going to use the 30 messages. So I'm going to just do a simple sequence of 30. That's going to decrypt all of the codes. But I need to find who committed the crime that's listed in the questions. So here, what I'm going to do is I'm going to create a table that's going to help me identify the sender depending on each code. So my first column, before I create the table, is going to be a combination of sender and receiver. I'm going to use that to then find the sender, which is the text before my dash. My receiver is going to be the text after the dash. And then the code is simply going to be taking all of these values and putting them into a single column. Now I can XLOOK up the code along that table and find who the sender was. All right, now we got to go put them in the order that they are in the case, which is basically this crime order. Now for each of these crimes, we're going to see where this is actually a number, where I can find this in my list. So you see for octahex, we can find it in the first. I'm going to X match that along the list, and I'm going to apply that to all of the other crimes to then get the correct order of them. Now that I have that, I'm going to use that order to find the suspect. Now I can copy that, bring that back over to the case file. Those all check out. Let's go ahead and take care of the bonuses. Bonus 1, convert all the characters in levels 1 and 2 to a corresponding code in Unicode numbers. What is the average? Now here's a little trick. We can just simply average these 4 ranges because they want the characters given and the answers. When we average them, it's going to take out all of the values which are not numbers. So that will work out just fine. We want to round to the nearest integer, which is basically 0 digits. What is the common ordinary shift in 3 and 4? So remember that shift of -1 is equal to a shift of 25. So basically what I'm going to do is I'm going to take all of the shifts in levels 3 and 4. I'm going to take the mod value with a divisor of 26. That's going to give me a number of 0 to 5 for all of these shifts. And then I can put this in a group by function. The group by can then tell me how often each of these shifts appear. There we go. Using a sort of -2 takes the most common one at the top, and that will give me the answer to bonus 2. Bonus 3, determine the Unicode numbers of all the symbols in the correspondence tab, and what is the sum of all of those numbers. Now there's a couple of ways I could have done this. I could have went back to my model and just simply added all of them together, or I could just take them from this sheet, split up all the characters, and then find the Unicode value of all those characters, and then simply just sum everything together. I'm going to go ahead and do the second strategy here. So here I've split up all the characters. I can just wrap that in a Unicode function. That's going to give me the Unicode value. Paste that all the way down, and then just simply sum up that massive group of numbers there. Bonus 4, on the people tab, what is the maximum shift between any given pair of people? So you see we already created a table to identify the sender of the message. Now we're going to create a second table to basically reverse that table. Basically taking the 2, putting that as the sender, take the from, put that as a receiver, and then find out what is the code between those people. And then over here, we can just do a simple difference between them. Now, the blank values, they're not going to calculate well, so I'm going to put that in an if error statement, and we just simply need to find the maximum value in this column. Last bonus, on which day did the most crimes occur and how many times has it appeared? So we're going to go back to our model, and we are going to take the first word in each of these messages, and we are once again going to do that group by function to see how often each of those words came up. So we see Tuesday came up the most. It came up 8 times. I'm just going to type this one in manually, and that is going to solve our case. There we go. Very nice solve. 18 minutes. I'm very happy with that, and I hope you are happy with that too. This was a really fun case. I love these cases, and I hope you enjoyed them just the same. If you did, make sure to give me a like, give me a subscribe, and I look forward to seeing you for the next one.